open this computer. Let me see. All right. So the first thing we're looking at today, and I want us to walk as fast as possible today, okay?
Okay.
Good. Dividing whole numbers. I remember we did this the last time, but we just have to, continue and try to finish it. 324 pounds of oranges have been divided into 7 boxes. Yeah. Okay. How many pounds in each box? Then the basketball team scored 3,675 points over the course of the season. If there were 35 games, how many points? Okay, let me check on the questions to see. Yeah, I think we already worked on all of these questions. You remember? You remember, right? Maybe we didn't turn it in, okay?
Okay.
And I can remember that we already did this last page, so let's just turn it in. Then we'll move on, okay?
Okay.
Yeah, I don't know why it says this. Maybe that last aspect wasn't done. Okay, let's keep going. Let's keep going. Now, dividing all numbers too, okay?
Okay.
In every division problem, there is a dividend, a divisor, and a quotient. The dividend is a number that is being divided into places. A divisor is a number that we are using to divide it, like the number of places. And the quotient is the answer. So when the divisor when the divisor does not go into dividend evenly, there is also a remainder. There is a what?
Major.
A remainder. So let's look at this process in this video. I want to share my sound now so that we can get to, let me see.
Long division is a method used to divide two numbers. It breaks the process down into smaller steps of division, multiplication, and subtraction. In long division, the number being divided, called the dividend, goes inside the long division sign. The number of equal parts that the dividend is being divided into is called the divisor. The divisor goes on the outside of the long division sign. As a dividend is being divided, the quotient is written above the sign. It is.
Now, Miggy, can you hear that?
Yes.
Good. Let me continue.
The result of dividing the two numbers. The amount left over after dividing two numbers is called the remainder. The remainder is written after the quotient with a capital R.
Okay,
in this
fine.
problem,
You can see this problem. The dividend is 75, the divisor is 4, the quotient is 18, and the remainder is 3.
The dividend is 75, the divisor is 4, the quotient is 18, and the remainder is 3.
Okay, fine. We'll move on. Let's go to the next session before we work on any question. It says find the quotient. Then we surely must have a remainder, okay? So 32 cannot divide into 7. Then we have 78. 32 in 78 is 2. 2 times 32 gives 64, okay? Then 78 minus 64 is 14. Then we bring down the next digit, which is 9. Is that clear?
Yes.
Then we say how many 32 is in 149? And that is 4. 4 times 32 gives 128. And we subtract to have 21. So that means our remainder is 21. Is that clear?
Yes.
All right. So we have seen, and we can use our multiplication to check it back, okay? He said, do you remember how to check the quotient that has a remainder? Multiply the quotient by the divisor, then add the remainder. So once we multiply, say 24 times 32, and if we add 21, it's going to give us 789. Is that clear?
Yes.
Good. This is another example. 1912 divided by 18. Yeah, we have 18 cannot divide 1, but it can divide 19 one time. So 1 is written above as a quotient. 1 times 18 gives us 18. Then 19 minus 18 gives what? 1. So you drop the next digit, which is 1. How many 18 is in 11? It cannot go, that is 0. You drop the next digit, which is 2. How many 18 is in 112? That is 6. 6 times 18 is 108. Then 112 minus 108 gives 4. Is that clear?
Yes.
Good. So if we want to check it back, we just multiply 106, which is a quotient, by the divisor 18, then we add 4, then it gives us back what we started with, which is our dividend. Then the next example, 3039 divided by 45. We could see that 3000 divided by 50 is going to give us 60. So our answer is going to be within the range of 60s, okay?
Okay.
Yeah, so what we have here is 45 cannot divide 3, cannot divide 30, but can divide 303 6 times. So 6 times 45 gives 270. So 303 minus 270 gives 33. Then we drop down the next number, which is 9. How many 45 in 339? That is 7. 7 times 45 gives 350. Then 315 minus 339 minus 315 gives 24. That is the remainder. Is that clear?
Yes.
Okay, there's a pop-up quiz here, which we're going to look at. Okay, so let's do the pop-up quiz first, then we'll work on the questions. Is that clear?
Yep.
Which number should go inside the long division sign? Miggy. Which number?
194.
290, that's correct, 294. How many times did 6 go into 29? How many times can 6 go into 29? Yeah, Miggy, sit right and answer this. How many times can 6 go into 29, Miggy? Like 6 plus 6 is 12, plus another 6 is 18, plus another 6 is 24. If I had another 6, that's 30, so I could see 4 times, okay?
4.
4, that's correct. What's the result of the first time you subtracted? So we can say 4 times 6 is 24. When you say 29 minus 24 gives us what? 29 minus 24 gives what? Miggy. 29 minus 24.
29 minus 24.
Yeah. (29 minus 24). Just count from 24 to 29. 25, 26, 27, 28, 29.
5.
5, that's correct. What was the only digit to be brought down? That should be the next digit, which is 4, okay? Then what is the result? What's the quotient when you divide 294 by 6? Okay, we say 6 in 29 is 4. Then we have 5. And 6 in 54. Oh, you've been distracted. 6 and 54 is 9, so the answer is... Yeah, the answer is 49. So
That is me.
Let's work on questions, Miggy. Are you ready?
Wait, it's not. Excuse me.
Okay,
Wrong one.
okay, okay. Okay. So, when the quotient of a long division has a remainder, it means the dash does not go into the dash evenly. It means the divisor does not go into the dividend evenly. Is that clear? Is that clear, Miggy?
Yes.
Okay, fine. So can we move to the next question now? Miggy, are you ready for the next question?
Yes.
Okay, fine. Next question. Okay, fill the blanks to complete the step for the long division. That is 300 divided by 22. Can 22 divide 3? No. How many 22 is in 30? That's 1, right?
Yes.
Then 1 times 22 gives us what? 22, right?
Okay.
Then 30 minus 22, gives us 8. That is 0, 8. Okay?
Okay.
Then we'll bring down the next digit, which is 0. So how many 22 can I see in 80? That's 3. 3 times 22 gives 66. Is that clear?
Yes.
Then, Miggy, what is 80 minus 66? 80 minus 66 is what? That's 10 minus 6 is 4. And 7 minus 6 is 1. That's 14. Then the remainder is what? 14.
Right. Okay.
14, yeah. So the next question, can you try this, Miggy? 47 cannot divide 9. Then 47 in 95 is 1. Or is 2, okay, because you say 47 times 2, it gives us, 47 times 2 gives what? 94. So that's 2. Is that clear?
Yes.
And that is 94. So 95 minus 94 gives us 1. That is 0, 1. Then you bring down the next digit, which is 9. Can 47 divide 19? No, that's a 0. Then if you going to put zeros here, then you still have your 19. Is that clear?
Yes.
Then the next digit is 8. So how many 47 can I see in 198? I could say, let's say, how many 47? Yeah. Can I see in 198? I can see 4, okay?
Okay.
So if I put 4 here, so I need 4 times 47, or simply put 47 times 4. And that is 188, okay?
Okay.
So 198 minus 188 gives me 10. So what's the remainder? Miggy, what's the remainder?
10.
10, good. So number 4. 54 cannot divide 7. So in 72, 54 can go once. Then I have 54. So what is 72 minus 54, Miggy? 72 minus 54?
2 minus 4.
72 minus 54. That is 18.
Okay.
Then you bring down the next digit, Miggy. Concentrate. Miggy, focus. So that's 187. How many 54 can you see in 187?
Focus.
Obviously, you can see 3, okay?
Okay.
And what is 54 times 3, Miggy? That is 162. 162. So, Miggy, what is 187 minus 162?
100 what?
187 minus 162. 7 minus 2 is 5, okay?
Okay.
8 minus 6 is 2. 1 minus 1 is 0. That is 25. Then you bring down 8. So let us check. How many 54 is in 258? That's going to be 4, okay?
Okay.
Then what is 54 times 4? That is 216. 2, 1, 6. Then, Miggy, what is 258 minus 216? 8 minus 6 is 2. 5 minus 1 is 4. 2 minus 2 is 0. So what's our remainder, Miggy?
It's
What's the remainder?
42.
42, that's correct. So we'll go to the second to the last question on that aspect. 15 cannot go in 9, but 15 can go in 96, adding 6 times. Okay?
Okay.
So 15 in 96, that is 6 times. So 6 times 96 is 90. Then I have 96 minus 90, that is 6. Okay?
Okay.
Then bring down the remaining digit, which is 5. How many 15 can go in 65? That's 4 times. 4 times 15 is 60. Miggy, what is 65 minus 60?
5.
5. What's our remainder, Miggy?
5.
5, that's correct. And to the last question before we go to Tony Kane. Let's say this. 88 can go in 3, can go in 32, but can go in 328. So how many 88, Miggy, when you say in 328? That should be 3, okay?
Okay.
And what is 88 times 3? 88 times 3 should give us 264, okay?
Okay.
Then what is 328 minus 264? 8 minus 4 is what? 4. 12 minus 6 is what? 6. And 2 minus 2 gives me 0. So that means 328 minus 264 gives us 64. Then you bring down the next digit, which is 3. Is that clear?
Yes.
Then we say, how many 88 can we see in 648? How many 88 can we see in, oh, I said 648, that should be 643. So how many 88 can we see in 643? That'll be 7, okay?
Okay.
So 7 times 88. So 88 times 7 will give 616, okay?
Okay.
616. Now we have a job to subtract. What is 13 minus 6, Miggy? Miggy, what's 13 minus 6?
What's 3 minus 6?
13 minus 6.
7.
7, correct. What is 3 minus 1?
4.
2. And 6 minus 6? 0. So what's our remainder, Miggy?
27.
27. So hopefully we're correct. Then we can submit our answer, okay? Then what's your grade for this?
For a perfect score.
Yeah, perfect score. So that means you should always concentrate, okay?
Okay.
Good. So let's keep going and see what's the next thing to do here. We want to interpret what the remainder means, okay?
Yes.
There are 82 squirrels in Nutmeg and Pepper School. The whole school is going on a field trip today. Each school bus can only carry 20 squirrels. Though Pepper is sure that they will need 4 buses because 82 divided by 20 is 4, remainder 2. Nutmeg insists that they will need 5 buses in order to fit everyone. Who is right, Pepper or Nutmeg? Yeah, who is right?
Pepper.
Why do you say Pepper? You remember 20 squirrels can be in each bus, okay?
Okay.
So if we have 4 buses, that's 80, but we want to take 82. So we need 1 more bus, right?
Yes.
So who is right? That should be Nutmeg, okay?
Okay.
Because, okay, so do you still think we only need 4 buses, Pepper? No, we need 5 because 4 won't contain them, okay?
Okay.
Now let's go to the next section. Pepper was right that 82 divided by 20 equal 4, remainder 2. Because of this. Then remember that in a division problem, the remainder represents the amount that is left over after dividing. So in this problem, the quotient showed that 4 buses will be completely filled up, but there would be 2 squirrels left over. Is that clear?
Okay.
So these 2 squirrels need to ride on the bus as well. So Nutmeg was right, okay?
Okay.
That's another bus, a 5th bus, will be needed to carry everyone. So they're going to need, can you see the 5 buses? 1, 2, 3, 4, 5. So there are only 2 in the last bus, okay?
Okay.
Now look at this problem. At Sunshine Bakery, bagels are packed by dozen. This morning, 823 bagels were made. How many full packages will they have to sell? That is to divide 823 by 12 because 12 is in a dozen. Is that clear?
Yes.
Good. Each package will consist 12 bagels. So to find the number of full packages, divide the total number of bagels by 12. That means 823 divided by 12. 12 cannot divide 8, but 12 can divide 82 6 times. That is 6 times 12 gives us 72. Is that clear?
Okay.
So 82 minus 72 is 10. Then we bring down 3, which is 103. So how many 12 can we see in 103? That's 8. 8 times 12 is 96. Then when we subtract, we have 7. So that means we're going to have 68 packages, okay?
Okay.
Then it's going to remain 7 left over. Is that clear?
Okay.
Let's look at another example before we go into questions by the next section. An 82-inch length of ribbon is being cut into 6-inch pieces. 6-inch pieces. After the ribbon has been cut into as many 6-inch pieces as possible, how much of the ribbon will be left over. That means 82 divided by 6, then we have a remainder. 6 and 8 is 1. 1 times 6 is 6. 8 minus 6 is 2. Then you bring down 2. 6 and 22 is 3. 3 times 6 gives me 18. Then 22 minus 18 gives me 4. Is that clear?
Okay.
So the quotient is 13 and the remainder is 4. So after 13 pieces of ribbon of 6 inches each has been cut off, there will be 4 inches of ribbon left. Okay?
Okay.
Now let's go to the next session. Use the context to interpret the remainder in a real-life problem. We've solved 3 word problems so far in this lesson. In the first lesson, the answer was 1 larger than the quotient. In the second problem, in the first problem, the answer was 1 larger than the quotient, which has a remainder of 1. In the second problem, the answer was the same as the quotient. And in the third problem, the answer was the remainder. Okay. Now, what we're going to do is to try to solve some problems. Let's go to the next session. Okay, let's try to solve these. Then we can work on questions, okay?
Okay.
Let's pop this up. 474 students are being bused to another location. If 32 students can fit on each bus, how many buses will be needed to fit all the students? Let's check it out. If we divide 474 by 32, 474 divided by 32, we're going to have some whole number, which is 14. But that doesn't mean we need 14 because that will be left over. Okay? Okay?
Okay.
32 times 14 gives 448. So we can say if we take away 448 from 474, we're going to have the leftover of 26 students. So 14 buses full, 26 students remaining. So we need another bus to house the to bus the 22 students. Is that correct?
Okay.
26 students. So that means we have 15 buses. Is that clear? Now sit right, Maggie, and look at this. This is like a quiz. Then 474 students are being bused to another location. If 32 students can fit on each bus, how many buses will be full? This time around, 14 buses will be full. Okay?
Okay.
Now, 474 buses students are being bused to another location. If 32 students can fit on each bus, how many students will be on the bus that is not full? That is 26. So that is the same question. So let's go to our questions to answer them from number 1. The dash in a division problem needs to be interpreted correctly to help answer real-life problem. That's the remainder, okay?
Okay.
Then the next question. We can use division to solve real-life problems such as how many desks are needed for 3 rows with 7 students in each row. Can we use that? Yes. How much older is Leila? How much older Leila is than her little brother? Well, that's not division, that's subtraction, okay?
Okay.
How many pencils each of 9? How many pencils each of the 9 students will receive if 56 pencils are shared equally? Okay, so we can use this, so think about the first one. The total cost of 2 sweaters, no. So this is multiplication. Then the first one is also like multiplication, but because we say sharing equally, we pick the third option. Is that clear?
Okay.
100 stickers are divided evenly between 16 students, 16 children. How many stickers will be left over at the end? That means how many 16 can we see in 100? Then we'll get the remainder, okay?
Okay.
So 16 in 100 is 6. And if we say 6 times 16, we get 96. Then there will be 4 stickers left, okay?
Okay.
2,000 pencils are being divided into packages of 15. How many packages can be filled? That means we have to divide 2,000 by 15, okay?
Okay.
Then the packages that will be filled will be 133, okay?
Okay.
And it's going to be there's going to be some remainder. Is that clear?
Yes.
There are 229 people attending a convention. Each table seats 8 people. What is the least number of tables needed to seat everyone? So that means after dividing, we still need a table for the leftover. Is that clear?
Yes.
So that is 229 divided by 8, because 8 at the table, we have 28 tables. Then there's going to be remainder, because if we say 8 times 28, that could give us 208. And if we take 208 away from 229,
Okay.
hold on, let me check on something there. We said there'll be 8 at each table, right? Right?
Right.
So 200, yeah, so 229 divided by 8, we have 28 tables, fine. But we want to find out the remainder. So if we multiply 28 by 8, we're going to have 28 times 8. That's going to give us 224. Yeah. So if we take it away from 229, we have 5 people left. So that means we need 29 tables. Is that clear? That
Yes.
is the last table is going to be used for the remaining people. Then the next question, 2,000 pencils are being divided into 15 packages. How many pencils will be left over? 2,000 pencils, 15 packages, that's 2,000. We are dividing by 15. So we have 133. So what is 133 times 15? Then we'll take it away from 2,000 to know the remainder. So we have 1,995. So we take it away from 2,000. We have just 5 pencils left over. Is that clear? Is that clear, Miggy?
Yes.
Now we have a few questions to go now. There will be 175 guests at a wedding. How many guests at the wedding, Miggy?
175 guests
Good.
at a wedding.
Good. Instead of a wedding cake, the bride wants to serve chocolate. Oh, not chocolate, cheesecake. Okay.
Okay.
If each cheesecake serves 12 people, how many should she order? So 12 people can share one cheesecake. So how many 12 can we see in 175? That is, okay, let's take that to the board and try to address this on the board, okay?
Okay.
Yeah. So that, can you see the board now?
Yes.
Good. So let's check on the question. This is the question that we are trying to solve. And we want to divide, see, can you see this, Miggy?
Yes.
So we want to divide the numbers 175 Yeah, make sure you're concentrating. Divided by 12. Can 12 divide 1? No. 12 is 17 is 1. 1 times 12 is 12. So, Miggy, what is 12 minus, what is 17 minus 12, Miggy?
5 minus 2 is 4. I mean 3.
Wait, no, 17 minus 12. Look at the board. 17 minus 12. Miggy, what is 17 minus 12?
17 minus 12 is.
17 minus 12.
Wait, I'm still thinking.
Okay, yeah, do it. 17 minus 12 is what?
5.
5, that's correct. So moving now. So we have 17 minus 12 is 5. Then we bring down the next digit, which is 5. So Miggy, how many 5 can I say in 55? I mean, how many 12, brother, can I say in 55? How many 12?
5.
Yes, how many 12 in 55? Try it. I want you to be involved in the remaining part of the questions, okay? To be deeply involved, not just by answering questions, but by working out some things. So, how many 12 can I see in 55? Go through your 12 times table, then you'll be able to get that. How many 12 is in 55? If you can go through your 12 multiplication table, like 12 times 1, 12 times 2, and so on, then you should be able to get it. So how many 12 is in 55, Miggy?
It's 5. 55.
What do you call it?
What?
What's the answer?
It's 55.
No, how many 12 is in 55? How many times can 12 divide 55?
5 remainder 1.
Yeah, you're saying something that is similar. You're saying 55 remainder 5. That means, but that means 12 times a number is 60. And you know that you have 55 at hand, but that is not what I asked you to do, Miggy, okay?
Okay.
So now listen carefully to what I asked you to do. Divide 55 by 12. Divide 55 by 12, okay?
Okay. Okay.
So how many times can 12 go in 55? Keep adding 12 together or keep multiplying 12. Read your 12 times table. Okay?
Okay.
Yeah, read it and let me hear it so that you can, 12 times 1 is what?
55.
12 times 1 is what, Miggy?
12 times 1 is. Cannot be.
No,
12
12 times 1. 12 times 1 is what? Read your 12 times.
12 times 1 is 12.
Okay. What's the next one? 12 times 2.
What?
12 times 2.
24.
Good. 12 times 3. See, try it, Miggy. 12 times 3. 12 times 3.
12 times 3.
Yeah.
36.
36. Good. 12 times 4. Can you hear me? 12 times 4.
48.
48. But if we go for the next one, that will be greater than 55. Yes or no?
Yes.
So we don't want to get there. So how many have we seen so far? We have seen 4, okay?
Okay.
So that means, how many 12s and 55? That's 4. Is that clear?
Yes.
4 times 12 is 48, like you said. So Miggy, it's your turn now. What is 55 minus 48? Yes, Miggy? 55 minus 48. Try 55 minus 48.
The answer is 7.
7, that's correct. So that means we're going to have a remainder, yes or no?
Yes.
So our remainder is 7. So our quotient is 14. Now let us interpret the question. Read the question for me, Miggy. Yes, read the question for me so that we can interpret our answer.
Would be 175 guests at a wedding. Instead of wedding, the bride wants to serve cheesecake. If each cheesecake serves 12 people, how many should she order?
So what do you think the answer should be?
The answer should be 7. 14 remainder 7.
Well, he said how many? So if they have shared 14 cakes, they need 1 more. So she's going to order for 15, okay?
Okay.
15 cakes. So let me share the screen back. Then we'll put 15 cheesecakes, okay?
Okay.
So are you ready to answer the next question, Miggy?
Yes, I'm ready for the next question.
Good. Let me bring it up. Now this one, a bride wants, okay, the same question, fine. She purchases 14 that serves 12 people each. If each one is served a piece of cheesecake, how many guests will not get a piece? That is 7. That's our remainder, okay?
Okay.
Because it's the same question. Now, let's check on this one. There are 2 more questions, but I want you to do the 2, okay?
Okay.
38 students are planning to participate on a 3-on-3 basketball tournament. Each team must have at least 3 students. What is the largest number of teams they can perform? Yeah, that is 38 divided by 3, okay?
Okay.
So what is 38? How many 3 can you see in 38? Read your 3 times. How many 3 can you see in 38?
4. I thought 4 trees.
No,
One.
in 38. In 38. How many 3?
It's 1 tree.
It's 1, 2, which is 12, right? Right?
Yes.
So if you get 12, that means there will be remainder, there will be 2 students remaining because that's 36. So he said 12 teams can be formed, okay?
Okay.
So 12 times 3 is 30. Now read the last question yourself and give me your answer. Read the last question, let me hear you.
100 stickers are evenly divided between 16 children. How many stickers will each child get?
Okay, so that is to divide 100 by 16, right?
Yes, 116 divide.
Wait, 100 divided by 16. So, what do you think? 100 divided by 16, let's try on the, okay, so 100 divided by 16 because there are 16 children. Each person will have 6 stickers and there will be left over, okay?
Okay.
There will be 4 left over and that is 6 stickers. So can we submit the answer now?
Yes.
Good, good. Let's see. What's the score?
100 again.
100
times.
again, and that's good. So what we have to do now, we are not going to continue here. We're just going to go to our piano, okay?
Okay.
Do you have your piano around you?
I have.
Have you practiced the song a little? No, you have not, right?
Not yet.
Not yet, okay. Let me bring up my piano so that I can play, then you will be able to see and play along, okay?
Yung door. Just before what teacher dribble.
No. It's okay. I'll close the door.
Just before what teacher dribble.
No.
Yes?
And excuse me.
Okay, okay.
Already back. Okay.
All right. So I'm going to play it now, but I want to try and share the notes on the screen. Do you have the notes down? Did you write it down? I mean the note to the song.
I haven't written the notes yet.
Okay, let me share it on the screen. Bless the Lord, oh my soul. Let's see it. I want to try and share the screen, okay?
Okay. I have to tell you something.
Yeah. Oh,
Do you know what happened
yes,
yesterday?
what you say?
Yesterday? It's all about
Okay.
my cousin. My cousin just had a fever. Just suddenly,
Okay.
my cousin suddenly got a fever yesterday.
Okay.
So they went home. So I was with my dad yesterday.
Okay.
Mom is with my cousin yesterday. So they went home and they went home immediately so that my cousin could rest.
Okay.
Then
So,
my cousin is already feeling better but still has a cough.
okay, he's feeling better already, right?
Yes, but she still has a cough.
Cough.
Still
Okay, don't worry. So you can always remember her in your prayers, okay?
Yes.
When
So
you
now
pray.
my mom is making her rest today.
Okay, no problem. So let me share the screens now so that we can see the notes of the song, okay?
Cousin will be going back to Philippines in 6 days.
Okay.
By 14.
Yeah, okay. So I'm going to play the song now, okay?
Okay.
Then I will ask you to play.
I'm gonna write the notes now.
Okay, write it down while I keep playing so you can rehearse it, okay?
Okay.
I want to make sure you are seeing the keys and playing on the piano, so let me try. Okay. Let me increase this a little bit. Are you hearing it?
Yes. I'm gonna try to play that.
Okay. So that is one part of it, but you could also play. So instead of playing the last that says C, D, E, G, C, C. So it should be C, D, E, D, C, C. So that G on the last line can go for D, okay?
Okay.
But if I played it in the form of a chord, you play it too. Like, so it's the two sounds that's going to come. So when you finish writing it, then you can try to practice it a little bit, okay? Okay, you are trying it, right?
Yeah.
Okay, good, good. Let me try and see if I can use a beat here to just play it. Let me try to add a beat, like test this beat. If I want to use, let me use this freestyle. Okay, fine. So. Okay, fine. I will try to record it again. Okay, so now let me try and use this beat, like, let me play it and see. Try it again. Are you seeing this? So did you hear that, Miggy?
That's it.
Okay, okay. Try to play your, I just created a beat for it here, okay? And let me try to see where I can do it. Let me just loop it first and see. I want to select these. Set to selection. So, Miggy, I just want you to watch what I'm playing so that we can round up, then you can practice later when you watch the video, okay? Is that clear? Now, come and watch it. Come and watch. Now, Miggy, did you hear what I played? Miggy, where are you? Come here. Let me see you. Yeah, come here. Come close. Let me see you. I can't see you there. I can hear you. Where are you? Let me see your face here. Miggy, you want to round up now, so come here, okay? You are where? I can't see you. Okay? Anyway, we're going to round up now. So you make sure you watch the video. Is that clear? Hmm? Miggy, come. Do you want me to show you again or you just watch it in the video and learn along? So let me just play it one more time. I'm going to share the screen here, okay? And you see it in the video. Is that clear? Miggy, can you see that? Miggy, come. Okay, Miggy. So that's what we're running up for today, okay?
Okay.
Yeah. Or do you want to watch it before I go? Do you want me to play and you watch before I go?
Yes, watch it.
I should play it and you watch, right?
Yes.
So that's what I'm saying. So I am using a beat. Later, I'm going to show you how to use your own beats too, okay?
Okay.
Then let me just play it one more time, then we round up.
Okay.
Mhm. I want to play now. Make sure you are watching them, right? And to the verse. So, that's where we'll be rounding up for today, Miggy, okay?
Okay.
And tomorrow we are still meeting for class, is that fair?
Yes.
So if we have time tomorrow too, we can play it a little bit, but are you going to practice before tomorrow?
Okay.
So that when we
Okay.
meet, when we meet, you'll be able to play it, okay?
Okay.
Yeah, goodbye for now.